All right, so this is a video log to explain the Fotojoe Slayer Exciter based on a Tesla coil version 1.0. This is the first one that we built, and I'm going to go through a couple of the little things before I tear it apart and go to version number 2. But this one is actually working pretty good. So this is a regulated power supply that we have here. First of all, let's turn on some fans because this is going to start getting warm. All right, so we've got a dedicated fan for one of the components, which is that high power transistor. Then we have another dedicated fan on this side. It's on a heat sink. So let me kind of go over this real quick. Let's turn on that fan just to keep the whole thing nice and cool. Just like a fan in a car, a fan in a computer. That's all it does. It keeps the components, pretty much cool. All right, so let me point out what the life of the system is. The heart is this little gizmo right in here, which is a high power transistor. That's going to send, first of all, we're going to pump about 16 to 20 volts DC, direct current, into the system. And this is going to amplify the whole thing. It's going to amplify it to the point where I'm going to send it over to a capacitor over here. And that capacitor is going to take the charge and build it up even more. Then it's going to go through a couple of other oscillator components that I have here. All these wires are loose because I'm just basically trying out different components before I weld, or rather I solder everything together. So we have here all of these components basically feed this primary coil. This thing that's loose right here is a primary coil that is wound around a secondary coil. This secondary coil is producing, the DC is coming in through this primary coil and is producing a very, very high charge on this secondary coil, and thus producing an electromagnetic field here. This is a huge magnetic field that is being produced. So the voltage that's coming in is a mere, say, we're going to start off, let's say, at about around 17 volts DC. By the time it gets to the secondary coil and through the top load, this toroid here is called the top load. The top load also is going to serve as a capacitor. So it's going to enhance all of that current, and the voltage is now going to jump to 2,241 volts AC. It's going to go from DC to AC. It's very interesting because the current is going to be rather low, so it's not going to kill us all, hopefully. So what is going to happen though, it's going to produce a beautiful magnetic field that is going to be capable of producing something very interesting, and that is wireless power transfer. The whole idea here is wireless power transfer. Now, if you look at my little chart here, thanks to Brent.
For who?
We have here, oh, there it is, the NPN transistor right here. That's the heart of the whole deal. This guy right here, which you can't see because it's behind this heat sink. So let's go ahead and turn it on. And there's also an LED here that should be on, but I blew it out earlier today. So I've got to put a bigger resistor on here. I only have a 47K. It should be like 100K. That's why I blew out. But the current is still working. So in order to see if this thing is working now, well, first of all, let me just explain how power transfer works. We take a simple bulb,
Daddy, look at the amps.
fluorescent bulb, and the amps, yeah, we're up to 1.23 amps. And this thing, there is no wires attached to this thing, and any fluorescent light that I bring to it, just automatically power is transferred through the magnetic field that is being produced by this coil. It's just pretty amazing how it works. I could just lay it down, even a big old one, a big old fluorescent bulb gets lit pretty much. And again, we're only at 15 volts right now. So I can start ramping this up, and if we don't blow the whole thing, we should be fine. I mean, look at this thing. There's no wires attached to any of this stuff. So now, there's also a very interesting thing that happens. If you come in close, you can see how the magnetic field is on ground, right? So I can attract the magnetic field by just putting my hand on it. If you look at this thing, I can bring it over. And we're arcing now. Look at this arc. This arc is being produced by this magnetic field. Check this out. And we're only at 17 volts DC. But there's about 2,000 volts going through this thing. But it's pretty low current. It's only at 1.36 amps. Which means that it really can't kill me. Now we can go over here and test it out. Check it out. Due to the skin effect, it doesn't really do much. It does burn the skin, but it doesn't electrocute me. Look at that. There's 2,000 volts going through this thing. Now there's a lot of plasma that can be produced. If you look at this closely, you can see the plasma. And check it out. Look at the plasma right there. Ouch. I don't know if you can see that pretty blue. That is the plasma being produced. It's turning into ozone. No, I don't want to set it on fire. So if you keep it moving, I mean, if you kind of just hold it in one place, yeah, it will burn. It's almost like a welding torch. And there's no wires, nothing attached to this thing. This is just done through the air. Look at this. Wireless power transfer. It's pretty amazing. I mean, look at this thing. It just lights up. But since I'm ground, right? Anybody can come in here and interrupt the circuit a little bit by just putting your hand in front of it. Here, Lucas. Try some of these things. Okay, here's a really good one, guys. Okay, check this out. I bought this CFL energy efficient bulb at Home Depot the other day, and I've never taken that out of the package. But check out the magnetic field that's being produced, how strong this thing is. I mean, look at this with no wires. This thing is still in the box. I mean, in the package, and every single one of those filaments is lit. Now this is version 1 of this contraption that I'm going to build. I'm going to build one. Now this only has 404 turns. So it's producing about 2200 volts. The next one I'm going to do, version 2, is going to have about 1250 turns. It's going to be really awesome. And the toroid is probably going to be maybe the same one or a little bit bigger. But it's going to be, that one's going to be producing about 3,500 volts. So hopefully I'll be able to get these streams way out. Instead of to here, maybe out to here. Okay, Lucas, go ahead and do your skin test.
I'm good.
You're good?
Yeah.
All right, I'll do the skin test. It arcs to anything. Check it out. It's not really electrocuting me. It's just burning me, that's all. Just a little bit of burn right there. No big deal. And that's only at, if you look at this over here, it's only at 16 volts. Now I can start pumping this up and the effect is going to be much greater. So let's go ahead and go to 20 volts and see what happens.
What's that?
Now the skin effect will be less if I have a second ground. Like, come over here, Lucas. If we have a second ground, if he's touching me, right? If he's touching me,
Look at the amps.
Okay, so if he's touching me and I go up here and I get shocked, it's less. The skin effect still works, right? I still get burned, but I don't get shocked. So in other words, at 2,000 volts, if the current was high enough, you'd be killed instantly. But this is really not even doing anything. You can't even feel it. There is an electromagnetic field, obviously, but if you look at the plasma that's being produced, not everything can produce plasma. But look at the ouch. Okay, that one got me. This one right here. Look at the plasma. I don't know if you can close in on that. But you see it right there? How nice that looks. See, the current is low enough where it doesn't really produce much of an effect as far as burning the paper. Now it can. We burned, plenty of papers, but okay, well maybe that one's starting to burn, but all that's being turned into ozone. That's pretty cool. I mean, look how cool that stream looks. And you can just put your finger right through it and stop it because I'm ground, right? So since I'm ground, I can go whoop, whoop, and interrupt the circuit. Now if you can close in on that and do a slow-mo, you can see the streamers as if you were since you want to go to Norway and look at the northern lights, this is something similar to that with the plasma. See, look at that. I could just interrupt the circuit by doing that. And that's a pretty good arc right there at just 20 volts. Now I can pump this up to 30 or 40 volts, but I'm afraid that my transistor may pop. I've already popped a few trying to experiment. Okay, so I think that is enough for the video log, just to show what version 1 looks like. Woohoo, that's a good, ow, that's a good one. 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 See how it's trying to, the magnetic field is trying to come around. All right, my power supply
Is that 2 amps?
is up to almost 2 amps, and the automatic fan is turning on, which means that my transistor is getting really, really hot now. But the fans are working really good though, because it's still supplying energy. Okay, so we're good. That concludes the Fotojoe Slayer Exciter based on a Tesla coil, version 1.0.